Hi, everyone. I'm Alex Larson. I'm one of the general partners at Blockchain Capital. We're one of the first venture capital firms to focus on crypto. We invest across the blockchain stack from infrastructure to low-level protocols to applications in DeFi and gaming and other areas. I'm joined by my colleague, Ryan Sproul, who started our engineering team.
Hey everybody, my name is Ryan Sproul. I joined BCAP starting the engineering team about 1 year ago. And during that time, I've had the chance to focus a lot on scaling infrastructure and across the stack for crypto infrastructure, but specifically working with the Fuel team while writing some libraries and a couple of articles and other pieces here. So yeah.
Today, we're having a conversation with Nick Dodson and John Adler, two of the co-founders of Fuel Labs, who've been developing applications and scalability research since the early days of Ethereum. This is going to be a pretty technical discussion around things like virtual machine architectures. So before we bring them on, I want to give a backdrop for the conversation and add some context for why we're really excited about Fuel. So the blockchain space is undergoing a transition from monolithic architectures to modular architectures. That means that we're going from an environment that is currently bandwidth constrained to a future environment where bandwidth will be abundant. And this is happening through Ethereum's move to dank sharding, as well as the efforts of groups like Celestia, who are building data availability infrastructure that comes with really high bandwidth. So in this future reality, performance is going to come from how well the architectures of execution layers are calibrated to the available resources. And today, most L2s are optimizing for bits and bytes, not for high bandwidth. And this is where Fuel is different. They take an approach where, given where the puck is going, how can we most efficiently use the available bandwidth to maximize performance while retaining Ethereum's security? And so FuelVM is a highly optimized execution environment that will be deployed as an optimistic rollup on Ethereum. It reduces a lot of the wasteful processing found in traditional VM architectures, and it parallelizes transaction execution, which means that nodes can be run on consumer-grade hardware and can be way more decentralized than other rollups. It also has a bunch of really nice features that make it safer and easier to build on, including account abstraction and a native trustless bridge to Ethereum. So your favorite wallets like MetaMask will work, and you'll be able to bridge over assets safely from Ethereum Layer 1. And so we think this is the most exciting part of the trade-off spectrum for new execution environments. Alternative L1s demonstrated latent demand for high performance, but they did so via centralization. And by and large, developers still choose Ethereum. Fuel adds a high performance option to the Ethereum menu. And so it lets you have your cake and eat it too, so to speak. And that's why our research team is super amped about Fuel. There are a bunch of really interesting things that we can dive into with the team, so let's go ahead and introduce them. Nick and John, thanks so much for joining us. Could you give us a quick rundown of your backgrounds and how you got here today with Fuel, maybe starting with Nick?
So my name's Nick, the CEO of Fuel, Fuel Labs. And yeah, I started with crypto stuff in around 2013, initially doing a lot of mining, and kind of moved from mining into building some of the first apps on Ethereum and working with very early, very buggy version of Solidity. So it was one of the first Solidity devs as well. Kind of early to Ethereum, and then moved into working with Consensus, doing apps and infrastructure there. And I worked with them for about 4 years doing that. And then after Consensus, essentially wanted to work on scalability and resolving some of the developer experience and also scalability issues that we see kind of continually plaguing Ethereum and also EVM-based ecosystems, and wanted to take a stab at addressing that. And John, who also was at Consensus, was someone that I had met. We'd had a lot of in-depth talks, and then after a very long discussion in a cafe, decided to start working on Fuel together. Yeah. John?
Great. I guess I'll go next. So, hi everyone. My name is John. I'm also one of the co-founders of Fuel Labs. I do protocol research and specification work, and generally coordinate our high-level engineering efforts. I first got introduced to the blockchain space when I was in grad school. My grad studies advisor was pretty involved in the early days of Ethereum and kind of got his students excited about Ethereum blockchains in general. I kind of took the deep dive when I left my PhD to join Consensus. I think it was in 2018. in the Toronto office. That's also where I met Nick, like Nick said. And then from there, it was basically do research into scalability. Next thing you know, we're over here starting Fuel Labs to build fuel.
Crazy times.
In that cafe to hear that conversation.
It was basically me probing John on how to break an optimistic rollup and why I didn't think it would work. And then after the 3 hours going like, okay, I think it will work. Something along those lines. Yeah.
I could see in a lot of, let's say, broken constructions for scalability over the years.
Yeah. It's pretty bad. It's pretty bad at that time. So, yeah. So where to begin?
Cool. Yeah. So I guess, I mean, it might be helpful just to start from the top with Fuel's been branding itself as this modular execution layer. So I guess just to level set a bit here, what exactly is a modular execution layer? What does that mean?
Yeah, so basically, modular execution is something that is kind of coming up with the, kind of the rise of modular blockchains as we see them. And it's sort of a different paradigm or a paradigm shift that's happening alongside with rollups, where essentially you have computational systems that are specifically designed for modular blockchains or modular blockchain stack. So in our case, that's kind of how we define modular execution layer. And in many ways, that's extremely similar to a layer 2 or a rollup. But we make a technical distinction that being designed for a modular blockchain means being designed for a significant increase in bandwidth potential. And so, we kind of define a lot of the existing optimistic rollups or layer 2s as far too bandwidth constrained and would likely not do well in a high bandwidth environment. And so that's sort of how we categorize or define ourselves and define our kind of underlying technology.
Right. And as John, you're both a founder of Fuel Labs and Celestia is one of these environments where you'll enable high bandwidth, but you also see Fuel as a rollup on Ethereum. So I was kind of curious about where exactly allegiances lie, or how you guys at Fuel at least are thinking about the Celestia world versus the Ethereum world, and generally your plan for deployment in this too.
Sure. Well, I mean, it's a philosophy of modularism, not maximalism. The Fuel or any modular execution layer can be deployed in a modular way on different data layers. That being said, there will be a deployment of Fuel. The initial deployment actually will be on Ethereum proper as a rollup with additional nice properties, like you can run an off-chain like client, like a bona fide off-chain like client, not just an on-chain bridge contract. So it'll be a full-on modular execution layer attached to Ethereum. That's something that is guaranteed to happen. But beyond that, in the future, there's no reason to constrain ourselves to one single chain due to maximalism. Whatever technology is best for the protocol and, more importantly, the users is whatever technology will be used.
Interesting. And you mentioned the bona fide light clients there. I guess can we just dig into exactly what that means and what benefits that gives to the rollup relative to just a normal bridge?
Yeah, so there's some subtle distinctions here between a light client and a rollup bridge. So a lot of rollups nowadays that aren't designed to be modular execution layers have a smart contract on Ethereum, and they will colloquially describe this as running a light client of the rollup protocol or the rollup chain. But that's not exactly what it's doing in almost all of these rollups. In almost all of these cases, what it's doing is it's actually just running a bridge that will determine whether or not, say, some 32 bytes posted periodically is valid based on some rules. And that's actually not the same as a light client. I'll give you an example. If you have a ZK rollup, like ZK Sync or Starkware or whatever, that uses state diffs instead of posting its transaction data, then you may know that based on these state diffs, the state root will be some 32-byte hash. But that doesn't really tell you, for instance, information of has my transaction been included in a block. So, if you're Alice and you want to pay Bob, sure, Bob can see his balance has increased by whatever amount was paid, but he doesn't know that Alice is the one who paid him, right? Because that information is not actually there. The only information you have is some state diffs. And like, in the Ethereum account model, for example, there is no information whatsoever of where did the funds come from, unless you have the full transaction data. So that's an example where, in striving to reduce the bandwidth footprint of the rollup, they've turned it into something that isn't a bona fide light client. They've turned it into just a rollup bridge, and they've lost the ability to do certain things, such as prove to an off-chain light client, or actually prove to any client, actually, that Alice successfully paid Bob. There are other optimizations, for instance, instead of using a Merkle root, Satoshi's Bitcoin design paper spent an entire section about light clients and said, hey, you can use a Merkle tree of transactions to show with logarithmic cost that a transaction has been included in a block. But if you don't care about light clients and you only care about, I'm running a full node, or I just want to prove to a bridge contract that some 32-byte state root is correct, you don't have to Merkleize those transactions. You can just hash them, or not even hash them, right? But then again, you're losing this property that this entire section dedicated in the Bitcoin design paper just for this property of being able to prove to off-chain light clients, or light clients in general, that a transaction has been included. And those are the properties that you lose if you focus exclusively on, I want to be a rollup. So if the Fuel protocol is really building towards a modular execution layer that someone can run an off-chain light client, know that their transaction has been included in the block with logarithmic cost, just like you can in a light client nowadays. Does that answer your question?
Yes, that's very interesting. And I guess, I'll let Alex ask whatever you can say.
No, yeah, I mean, I think that we're getting at something really interesting here that might be useful to underscore around trust minimization and how different systems compare on that vector. And so, John, I'd be really curious to hear, what does it mean to be trust minimized to you?
So I wrote a paper describing this particular property in an attempt to define it as formally as possible. But to kind of put it in layman's terms, something is trust minimized if you can be guaranteed to always be able to advance the state based on some arbitrary valid state, and also if you're guaranteed that no one can advance the state invalidly. So there's some particular rules that everyone agrees. I mean, obviously, there's presumably some constraints here that the rules are constrained in some ways, because if you can say, oh well, the rule is just anyone can do literally anything, then by definition this is obviously no one can ever steal money if no one owns anything, right? But I mean, for like any sane set of rules, it basically boils down to people can always move their funds or use applications on the chain, and no one else can misuse these funds or misuse applications by doing something invalid. And as long as you have those two properties, then that's sufficient for describing a protocol as being trustless, right? Which in a rollup world, you would think of it essentially as no one can freeze your money, and no one can steal your money. That's kind of the plain English interpretation of that. Which, I mean, if you think about it, as long as no one can steal your money and no one can freeze your money, and that includes freezing your money inside like some DeFi application, that is trustless, right?
Yeah, and then putting it back in the context of the previous conversation about light clients, what specific property does the light client give you that maybe another rollup might not have? If you don't have a light client, what do you lose about trust minimization there?
Well, trust minimization encompasses a lot. Like it's more than just, can I use this blockchain, but also can I use it in a way that is auditable and verifiable. Now we'll go back to the case of Alice paying Bob, right? If you only have state diffs and you don't have actual transactions anywhere in the block header, whatever you want to call it, Alice can't prove to Bob that she's paid him. So even though she's used the protocol as intended, and she successfully pays Bob through the protocol, she can't prove to Bob that she paid him out of protocol, and now effectively her money is burned, right? Or if Bob happens to be colluding with the block producer, then maybe also stolen, right? So that's a notion where you have this rollup bridge, okay, it all works and stuff, but the protocol is not trustless because there's more to it than just I can use the protocol as an island. You also have to be concerned about a user is a human, and the human is not on chain, right? The human is off chain, and how will they interact with the protocol? And there will be third parties that this human interacts with, and those third parties are also humans.
Gotcha. And then maybe Nick, you can talk a bit about how exactly Fuel is what about Fuel has allowed it to be easier to make light clients, or is it just a focus of the team, or is it some technical distinction?
Yeah, I think there's a few points there. So one is that we got to approach designing it from scratch. So we didn't need to factor in backwards compatibility, which is pretty huge. So you can re-architect and design things in such a way where you know what properties you're looking for from the outset at the design stage, which is much easier to encompass traits and things like light clients, trust minimized light clients, and even just the way that we've architected the UTXO model, the way that the architecture of the virtual machine works. All of these things impact how well you can basically build things like trust minimized light clients, but also make a system that is far more tailored towards the physics of blockchain processing, which is inherently different from normal hardware-based processing. And I think John, in his, basically training, computer science training and engineering, has more of an instinctual sense about the actual cost of what it takes to process in a blockchain, and that versus processing on hardware. So I think because we can do things from scratch and we can take in all the great design ideas from the current state-of-the-art stuff all the way back to the beginning of blockchain, we get to incorporate all the fun stuff that no one else gets to do, and then we get to do it our way, and the way that can factor in all kinds of design lessons. And not just that, but I think there's a belief with Fuel that every design decision we make now that's correct, or every design decision that we make that might seem small, they might seem tiny now, will have basically quadratic effect later, or some magnitude order of effect later under pressure. And basically, because we're spending so much time at that level, we get to incorporate all of these things into the fundamental design. So in the 5 to 10 year time horizon of the use of this virtual machine, the pressure and impact that we think it will see should have a much better time handling, I think, the kinds of volume that we want to see it handle than a lot of the other blockchains. So that would be my answer to that.
Yeah, and that's like an interesting point you bring up about each of these individual decisions. So if you just look back at how the EVM was designed initially, it was essentially pushed to market as fast as they could, in a reasonable amount of time. It was a rush to market along with a lot of technical decisions. So kind of curious how you guys are balancing that same trade-off space. It's each of these individual decisions adds an extra week or two, and it pushes you out further. And on the competitive landscape now, there's a lot of rollups coming out. How do you balance between something that's going to last a decade versus something you want to get to market in a year or two? Or we could talk more about that.
It drives me crazy, but we just wait another week, or we just push it out a little longer, but only because it is really important. So I think the whole mission, at least for me, is that it wasn't done correctly the first time, and it caused enormous amounts of problems for us. And people are being tricked into thinking that things are fine now in terms of the current scalability landscape, and that we don't need to worry about these things. When in fact, I think that is literally just projects pulling the wool over the eyes of a lot of people, when in reality, these are the most pressing and most problematic things that we can't change because of backwards compatibility. So in my purview, given the current space, I think taking the extra week now has compounding impact later. So, it's a huge advantage, basically. And looking at the short-term or mid-term competitive advantage doesn't make a lot of sense, because it's either blockchains are going to be around for a very long time and we need to build a better machine that's going to stand that test, or they're not, and then it didn't matter anyway. So yeah, but I think John can probably speak to this as well.
No, I mean, that was a pretty good answer. There are fundamentally certain things that will never be changed on layer 1 Ethereum and the layer 1 EVM, again, due to backwards compatibility. And it's kind of foolish to launch a brand new state space and then be constrained by the backwards compatibility by just forking Geth, right? A lot of decisions both in Geth and in the EVM, the Ethereum protocol, are constrained, again, due to backwards compatibility. I don't really see it. Like, there have been many proposals to change these things, but they haven't gone through in years and years and years, because just even making minor changes that aren't breaking are enormous undertakings, let alone anything that is breaking. So having a new state space is kind of the perfect opportunity to experiment with all of these proposals that have been suggested over the years, but that couldn't be implemented, and actually implementing them. And in that regards, the Fuel protocol is years ahead of basically any other protocol in implementing these improvements, right? You'll hear other protocols saying, hey, we'll start with the EVM, and then we'll think about improvements to it. And it's like, well, Fuel has already been working on those improvements for years, and we're literally years ahead of any other protocol in improving the EVM, because the Fuel VM is ultimately based off of lessons learned from the shortcomings of the EVM, using the EVM as a base and just massively improving it.
Yeah, and that start with EVM and switch later, like that strategy just doesn't seem possible at all. Like once a single dollar hits your system, like you hit that backwards compatibility problem. And yeah, I see this. It makes a lot of sense why to like really be careful about this thing. But yeah, I think we can switch more into some of the other differentiators between Fuel and other rollups. I think we've mentioned the UTXO system briefly while discussing like clients, but I think, yeah, that could be a helpful place to kind of to start with one of the biggest core differences, which is the data model. So I guess I'll turn to John. Like, what is the reason that we've gone with the UTXO model here? Like, what are the great benefits we get out of it? We'll talk a bit about parallelism and all that in the future. Yeah.
There's a few key benefits to using UTXOs over accounts. Even though a lot of these benefits can be replicated in the accounts model with doing a bunch of hacky stuff, there are just a bunch of nice things of using UTXOs directly, because even if you did those hacky stuff in the account model, it would just end up being the same as the UTXO model, just with extra steps and with extra baggage. So at that point, you might as well just go straight for UTXOs, which have kind of been a recurring theme in the blockchain scaling space of, anything anyone does that scales an account-based blockchain ends up looking somewhat or more exactly like UTXOs. This was especially the case in like ETH2, in the ETH2 like sharding research days, right? There was a lot of discussion about the execution environments and stuff like this, and a lot of the research there was basically just some isomorphism on UTXOs. So what do they give us? The first thing they give us is effectively a strict access list. So every contract that a transaction will touch is specified in the transaction itself. So you can just look at the transaction and say, hey, this transaction is going to touch these contracts. You don't have to execute the transaction first, because that could be very expensive, right? If you know beforehand which contracts every transaction will touch, then you can execute transactions that touch disjoint sets of contracts completely independently, because they're guaranteed to not have any dependence between the two, because they don't touch the same contracts. Again, you can replicate this in the accounts model, but then you need strict access lists. And when you have that, then you're going pretty close to already what UTXOs are. This is needed for parallel transaction execution, like I said, because you can execute them in parallel. And the reason you want parallel transaction execution is to unlock the full resources of computers nowadays, right? You can look at various graphs and stuff of, transistor count versus clock speed. And basically for the past, 15, 20 years or so, it's basically flat. The clock speed is basically flat. Like single core clock speed is basically flatlined. It doesn't grow anymore, let alone grow exponentially. Okay, maybe it increases like very, very slowly. Like when I was maybe 20 years ago, CPUs were running at 4 gigahertz. Now they're running at 5 gigahertz, right? Like, sure, I guess IPC has increased a bit, but still, there's only so much you can do realistically on a single core. But what has increased exponentially over the past 15 years has been core count, right? And the amount of CPU cores that processors have, and therefore the number of parallel execution threads they can run. So, if you don't leverage those, then you're not leveraging the thing that is increasing with Moore's law exponentially every year. You're just leaving a whole bunch of your computer not used. So that's why it's very important to leverage parallel transaction execution. That's the first thing UTXOs give us. The second thing that's critical is you can have fraud proofs with UTXOs without needing a global state tree. So in Ethereum, they have a single tree for like a single Merkle tree for the entire Ethereum state. And this is an issue because to update any account, you have to make an update into the tree, which in computer science terms seems cheap because it's like, oh, it's logarithmic. Anything that's logarithmic you can just ignore in computer science terms. But in practice, that's not true. And it's especially not true when those logarithmic things are sequential and they involve discretes, which in this case they do, right? And it's also especially bad when that thing, the tree of all these things needs to be stored in a database. And, a database is not flat in practice. Like in a computer science terms, you can say, I have effectively unlimited random access memory. And in this random access memory, I can do like a constant time lookup of anything based on some hash index. But in practice, that's not how it works, right? In practice, you physically cannot do that. First of all, because you don't have infinite RAM, and secondly, because it just does not physically work for you to do an actual constant time lookup into 100 gigabytes worth of hash table. Or in the Ethereum state, I think the Ethereum state is more than 100 gigabytes. It's like in the order of 300-400 gigabytes. It just physically does not work. You actually have to store that tree within a tree itself physically. So now you have this write amplification process, and it's all going to disk, or I guess an SSD, and it's all sequential, and this happens to be a huge overhead. So with UTXOs, we remove the global state tree. So each contract has its own local tree, but it's much smaller, and it's an individual contract that has the state tree. So you can do cute things around database optimization since it's all local. But we remove the need for this global tree, which is just enormous on Ethereum, on the order of hundreds of gigabytes. We remove the need for this global tree while simultaneously enabling fraud proofs without this global tree. So it's like killing two birds with one stone, where just full nodes are now much cheaper because they don't have to contend with a global tree, and both the size penalty of having a global tree along with the lookup penalty of having things in 2 layers of trees. You remove that, and now you have fraud proofs without that. So those are kind of the two major things that using UTXOs gives us. It's a combination of parallel transaction execution and fraud proofs without a global state tree, and also just not having a global state tree in general. Those are the main things. There's a bunch of smaller, minor things that you can do. Things like, for instance, if you lock a UTXO behind a predicate, you can actually do things like an atomic swap or a native multisig with a predicate, or verifying signatures from MetaMask or Solana, like a Solana wallet or a Cosmos wallet. You can do various cute things because you can lock coins behind predicate spending conditions, which is effectively account abstraction. So UTXOs happen to be a very cute way of doing account abstraction without all the downsides of the current proposals for account abstraction and the accounts model. So
yeah,
that's the TLDR.
I want to mention that when John says cute thing, it's more like one of the greatest things we can actually offer via the system, and is hugely impactful on actually every use of the entire system. But yes, those things are very useful, particularly because it's essentially account abstraction. And it's essentially what, for years, I needed to build any sort of reasonable user experience flow that I couldn't because of the way the EVM's constructed. And it basically held the entire ecosystem back probably a decade or more, just on the basis of the fact that you couldn't create something like an account abstraction pattern. And so, Create 2 was the biggest innovation that Vitalik and everyone could implement reasonably without breaking everything. And that was just simply still not good enough because it just didn't cut the kind of system that you really need to, again, if you want to reach global accessibility, you need account abstraction, basically. That would be my thesis on that. Yeah.
I think we totally agree. The fact that we manage private keys and seed phrases and that's still our user experience is just unrealistic. This is going to be what's going to get the next billion users onto crypto. And I think starting from the beginning with account abstraction as a default feature, and it sounds like even UTXO just enables it by default. It's just one of the core features of the data model. It's not even a design decision, which it seems like just the obvious path forward. But I guess we can talk more about. Oh yeah, go ahead.
No, I was just going to mention that. I think and just to kind of go into even some of the crazy technical ramifications, you can, in Fuel, you'll be able to send funds with a Solana key or with a Cosmos key You won't need an Ethereum key, for example. You can use MetaMask and Ethereum addresses, or you can use Fuel addresses. You can use any number of different combinations just because of account abstraction via predicates, and because essentially Fuel enables this sort of thing at the application level without hard forks, which is really wild.
Yeah, and that's the key distinction. Any chain anywhere could support Solana, Solana wallet. I guess it's the Solana signed message from a Solana wallet, or a Cosmos wallet, or a MetaMask, if they hard fork stuff into it. But with account abstraction, you can get it at the application layer, where like any random user can go and say, hey, I'm a Solana user. I want to use my Solana wallet instead of the Fuel wallet to hold my key material. And then they can just do it without asking anyone for permission, without any governance, anything, no hard forks, no nothing. They can just write a predicate and sway and just deploy it, and they're done.
Yeah.
And this kind of thing is a pretty big distinguishing factor for Fuel. It's not just about performance. Like we've talked a lot about parallel transaction execution and the performance and so on, but it's not just about that. It's also about the flexibility that the system offers in ways that there were a lot of things developers wanted to build, like Nick was just saying, he wanted to build some things, but Ethereum was not flexible enough. It's Turing complete, yes, but that's only the virtual machine, right? There is a protocol outside the virtual machine, the transaction execution protocol that exists, and that cannot do everything. And the Fuel protocol, transaction execution logic, also cannot do everything. No protocol can, but the Fuel transaction format and transaction validation protocol is much more flexible based on learnings of people wanted to do things on Ethereum, not because the transaction format and general transaction processing rules weren't flexible enough.
So, John, one of the, we've been talking about account abstraction here and what enables that in Fuel. Maybe it's worth doing a little bit more of an introductory bit on predicates in general. What are they? Why do they enable account abstraction? And why have you guys built them into Fuel the way you have?
Sure. So the TLDR and account abstraction, it's basically a way to define the validity rules of a transaction. And there's two parts of executing a transaction on Ethereum and on Fuel, because Fuel works similarly to Ethereum. There's some set of things you can do to check that a transaction is valid, like when you receive it in the mempool, for instance. And then there's a set of things that the transaction will have as effects. As an example, I could have a transaction on Ethereum that says I want to swap some Ether for some DAI on Uniswap, right? So I'll call it the Uniswap pool contract, right, with some particular call data and so on. And on Ethereum, the only thing you can do to change the validity of a transaction, or rather, what is the validation logic of a transaction for transaction validity, is there enough Ether to pay for gas in the user's balance, and is the nonce correct, and is the signature valid over this transaction, right, for that account. Those are the only three things. Everything else is not related to transaction validity. Everything else is related to the effects a transaction will have. Once that's done, once those things are checked and the transaction is checked to be valid, right, the transaction gets sent to the network, it does this thing, and then it'll have an effect. Either, it swaps, maybe it swaps for a particular amount, depending on the value of the pool, depending on if you got sandwiched. Well, this isn't even if anymore, you'll get sandwiched. And then maybe if the slippage is too low, maybe the transaction reverts, right? But a reverting transaction is not an invalid transaction. It's still a valid transaction, but its effect is a revert, right? Account abstraction actually allows you to program the validity rules of a transaction, not its effects, but its validity rules. As an example, imagine you could lock a coin behind, or I guess on an Ethereum account or whatever, behind some logic that says, you instead of checking a single ECDSA signature over SecP 256K1, you would check, say, a Schnorr signature or ETDSA signature, right? Because you want to use Solana or Cosmos, right? That would be an example of some programmatic logic you would add through account abstraction. Now, Fuel supports what we call stateless account abstraction, where basically the validity rules that you can set for your coin are stateless. In other words, they do not have access to contracts or storage or anything like that. It's some condition, and that condition either evaluates to true or false, depending only on the condition itself and its input, and that's it. So it does not have access to any side effects or any state. Therefore, you only have to check it once, right? If something is stateless, if something is a pure function, you only ever have to execute it once to know whether it's true or false, and that's it, right? Why is this important? If you have stateful account abstraction, and the Quilt team back when I was a consensus doing ETH research, towards the tail end was doing some research into account abstraction. But if you have a stateful account abstraction, the issue is that someone can launch a denial of service attack by doing things like making the validity of a transaction flip-flop. And if a transaction becomes invalid due to stateful account abstraction, you cannot blacklist the node that sent it to you, because when they sent it to you, it may have been valid. And this inability to blacklist nodes at a peer-to-peer layer that send you an invalid transaction is a denial of service vector, full stop. So any chain that advertises stateful account abstraction means they don't know how to design a protocol, because they don't understand that this is a denial of service vector. And ironically enough, stateful account abstraction is the same thing as censorship. What is censorship? Right? When people were worried about censorship of Tornado Cash, right? People going all over Twitter saying you cannot censor on Ethereum, because if you do, it's a denial of service vector, right? Because if someone attempts to censor a transaction that, say, touches the Tornado Cash contract, right, then they can similarly be denial of service, where someone can just send a bunch of transactions, make the block producer, spend a bunch of resources to execute those transactions, but not pay any gas, right? And then the block producer can't even blacklist them, because whether or not the transaction touches Tornado Cash depends on the execution of the transaction, not the validity. But for the censoring block producer, it would affect its own transaction validity rules. In other words, censorship is actually changing the validity of a transaction in a way that depends on the execution of the transaction. So stateful account abstraction. They're actually the two things are exactly the same. They're isomorphic. So just like how Ethereum cannot, you can't censor Ethereum unless you open a denial of service vector, you can't have stateful account abstraction without a denial of service vector. So that's why Fuel supports the best form of account abstraction that we know how to design today, which is stateless account abstraction. Now, how do we do it? And there's like a long preamble of what it is, but how do we do it? It's very simple. We use this thing called predicates, which is just some fancy computer science term to mean some pure logic, right? And every coin can be owned by a predicate, hash technically. And then if you want to spend a coin, you just reveal the predicate and reveal some input that makes the predicate evaluate to true, which is a long-winded way of saying you satisfy the predicate with whatever conditions it wants. It could want one condition, or it could want like one of several conditions. For instance, it could say if enough time has passed, one signature is enough. If not, you need like two of three signatures, something like that, right? You could basically describe any pure logic you could possibly want as a condition, and as long as it's satisfied in some way, then you can spend the coin. So this is how we enable stateless account abstraction. Nick, did you have anything to add on to that?
I mean, maybe just for a simplified version of a way to conceptualize predicates, or at least the way that I like to explain them. In Fuel, we have not just smart contracts like Ethereum, but we also have things that are called scripts. And so scripts allow you to just make a transaction that can do things like multiple calls and actually do a lot of user experience things that we've been wanting for a long time. But in addition to thinking through that, there's predicates. And predicates are like scripts, so they're similar. They have certain constraints, so they're not fully fledged like scripts are. But you can think of a predicate as just a script-like thing that if it returns true, then you can spend it. So if the script says, yeah, this is all good, you can then whoever actually reveals the predicate and meets those conditions can spend the coin. But what's crazy is it's not bound to a certain account or who can spend it. Really, you can design predicates in all kinds of ways where anyone can spend it, or certain people that can reveal certain conditions. So essentially, it gives you an incredible amount of flexibility. And then while the predicate itself is simple in the nature of how it processes and the way that our predicate design works, there's something neat about this, which is that the predicate can introspect to the transaction data, which essentially allows you to properly constrain the transaction in a certain way. So you can constrain design of transactions, and that is where it's most powerful. So while the predicate can't do everything, it can't call contracts and stuff per se, it can constrain the transaction in saying that this transaction must call this contract or do this thing. And that's where the superpower comes, because now you can basically not just say anyone can spend this, but you can say under certain transactional constraints, can this be spent? And that kind of computational system is very, very powerful. And we're just scratching the surface with Fuel in terms of the potential of what that means. But we know count abstraction like things are one aspect. We know that fully atomic order book exchanges that might be the most atomic order book exchange design you can ever construct is another avenue. And I'm sure there's numerous other things that will come about with predicates that we don't even know of yet.
Yeah, and the best part about all this is it doesn't consume any gas, assuming it's invalid. I mean, obviously, if it's valid, the size of a predicate, etc., there's going to be some cost to it. But if it's invalid, it doesn't consume any gas because this affects the transaction validity rules. So this allows you to do very interesting techniques. Like Nick said, you can have an order book exchange. There's actually, I think, in our Sway applications repo, I think there's a demo of someone wrote a predicate to do atomic swap that is enforced at the predicate level. So the predicate will actually introspect the transaction and say, if the input to the predicate is whatever, X amount of ETH, the output says it must be at least Y amount of DAI. And anyone can then fulfill the remaining conditions of the transaction so long as it satisfies those conditions. So you can do very interesting things and very powerful things that rely on off-chain coordination, and therefore never actually, all that coordination does not go on-chain and does not incur a cost to every single user running a full node on the system, but is rather only a single party that is constrained by the rules of the predicate. So you can't cheat. It's a trustless, just a trustless third party that is completely permissionless. Anyone can act as this person. Just coordinates various things, and the next thing you know, you have a swap happening on chain, effectively almost zero cost.
It strikes me that this is a very ideal solution for the next generation of decentralized order book exchanges in particular. And John, you had mentioned censorship resistance. I want to double click on that in that vein in particular, because I think one of the underlying assumptions of moving to a roll-up model is that we get to shift the trust model from an honest majority assumption to an honest minority assumption, which lets us use more powerful hardware, or at least that I think is the naive interpretation of what a roll-up lets you do, which says, okay, great, we can process more transactions and validity is guaranteed by some sort of a proof system, whether it's optimistic or ZK proving. And then we've seen, does that work today for a group that's literally trying to build a super high performance order book exchange in DYDX? They tried it with the ZK rollup on Starkware, and it didn't meet their decentralization requirements. And I think the place that we're at now is all the rollups are sitting here looking at, well, can we actually decentralize the sequencer sufficiently to enable these types of super powerful applications? And it strikes me that the model that you've built is more or less an answer to that problem, where on the one hand you have the ability to execute transactions in parallel via an optimized UTXO model with access lists. So you more efficiently use the threads and cores in a CPU, and you can get more out of the hardware and therefore use less resource intent or less advanced hardware, and can actually make that accessible to people who want to run nodes. And then at the same time, you cut waste in the VM architecture with new styles of execution like scripts and predicates. And so combined, I mean, to me, this seems like a foundation that you could have more success decentralizing a sequencer with, and therefore enabling these really powerful high performance financial applications that require decentralization. Is that a big part of the impetus for you guys in the design choices that you've made?
The thing I find most fascinating about it is anyone can just go and build a blockchain without a light client, to be honest. It's not nearly as exciting. So blockchains that are just being thrown together that don't care about decentralization, don't care about the properties of things like censorship resistance. To be honest, you can go do that today, and there's a bunch of them, and they throw caution to the wind, and they essentially have a system that doesn't meet anywhere close to what the original idea about peer-to-peer blockchains and censorship resistance and decentralization would be. And I think an interesting aspect or a side effect of Fuel's inherent design after cleaning everything up and being designed the way that it is that we can actually retain the properties, the really nice properties of peer-to-peer blockchains and decentralized design and censorship-resistant design, while enabling things like highly efficient order book exchanges. And so you actually can have your cake and eat it too with this approach. And I think that is a superpower that uniquely Fuel has that most of the other chains, including new layer ones, just don't have, because they're not thinking about how do I truly retain the true nature of these existing blockchain systems that are successful, and instead just go to how do I build something quickly that will, meet needs and essentially just, fulfill a certain sector of the world that is more financially inclined than I think values and principle inclined. Yeah.
And it kind of gets to the point of like what actually is the bottleneck for all of these systems, the ones that have maybe like kind of taken the more naive, quick to market approach, where they maybe forked Geth, and they're running faster right now because they turned the knobs on Geth a bit, but at the end of the day, they're going to run into kind of the similar problems. Like the state is exploding. You're talking about this multi-level disk read stuff that John was talking about before, and Peter from Geth has mentioned multiple times, is like, this is the bottleneck. It's not consensus. It's like these state reads. And like, I guess Fuel from your guys' perspective, like, how do you guys think about this state bloat problem? And I mean, the UTXO by design and like the predicate design and all of these things think about this as one of the core principles. But I'd like to kind of hear your perspective on like other people's approach to state bloat, how we're ignoring it, and like how you guys are approaching it differently.
So I'll just say before John has some commentary here, so I've been to basically every DevCon except for Zero. I would have gone to Zero, I bet, if I was around during that time, but I wasn't. And I've talked with the lead Go developer every single time since DevCon 1, all the way through to now, I guess, 6. And always the things that they talk about in terms of where they're spending most of their time in maintaining Go Ethereum is essentially state. And it almost, in DevCon 1 and 2, it wasn't so much of an issue because there wasn't a lot there. So it was a very different idea about what the client was. But basically, as the DevCons have progressed, and as I've had short, quick conversations with the lead Go Ethereum developers, every time it's progressively gotten worse to the point where just optimizing, per state.
Yeah, to kind of echo that, I definitely remember watching some of the earlier presentations on Ethereum when they're like, "Oh, we can run a node on a Raspberry Pi," and the next thing you know, a few years later, it's like, "Well, I don't know about that," or if we do, it needs some like fancy SST solution.
Yeah.
So state growth is a problem that all blockchains face, and you need some sort of way of mitigating this in some way. The nice thing of using UTXO is, like I mentioned earlier, is you don't have a global state tree. Without a global state tree, it means that you can mitigate some of the penalties of having 2 layers of trees, one logical and one physical, and also just makes the state size smaller, period, because you don't have to store the tree. It just doesn't exist. That's already a good thing, but that being said, it's maybe some constant, some non-trivial or constant factor, but it's still not like an exponential decrease in the amount of state or etc. So, we do need additional solutions. That is something we have been thinking heavily about. I've given several talks at ETHCC and some maybe ETH Denver previous conferences about resource pricing and how we think about resource pricing, along with collaborating on various researchers on this topic, because it really is all about resource pricing. It's one of the biggest topics, or the most important topics when it comes to designing blockchains. How do you price resources? And there's not a silver bullet answer that I can give you and say, well, I have everything solved, you just do this. But there's various mitigation strategies you can employ. For instance, you can make state rights more expensive. You can do notions of state expiry, which happens to be very convenient because of our UTXO model. If, for instance, a UTXO has not been touched in a while, then you can just expire it, which I guess has been discussed. It has been discussed in Bitcoin for a while, right? It's like, if no one's going to touch their UTXO for 10 years, do they even own it, right? If they can't even be bothered to move it. Of course, on Bitcoin, if the block space is constrained, maybe there's also the variable of transaction cost and so on. But that being said, when it comes to smart contracts, at least, if no one touches a contract for 5 years, can you expire it? I mean, there have been proposals on Ethereum and for the EVM to do state expiry or some sort of state rent or things like that. You can also do things like there's various Qt optimizations you can do because of the fact that contract storage is local, or storage for each contract is like local to the contract itself, and we don't have a global state tree. You can actually do cute things like store the entire state of contract just as leaves. Just store the leaves, don't store the inner nodes of the tree in like a very compact form. And then since you know beforehand which contracts a transaction will touch, you can actually like deserialize them and expand them and compute the entire state tree and put it into RAM. Not an SSD, but into RAM, which will greatly mitigate the performance penalties of having this like layer of trees, because RAM is in fact constant time access across the entire RAM. Well, I mean, modular some physical stuff like pages and whatnot, but it's much more performant at random access than SSD because it's literally in the name, random access memory, right? It's designed for this. So this only works though if you have strict access lists. If you don't have that, then that means you have to do some weird blocking thing where when you get to a new contract that's called, then you have to go load it from disk and put it into RAM, and that's that would be a blocking process. The entire execution of the contract would halt there, which is really horrible, right? But if you can preload this because you know which contracts a transaction will touch, then you can preload it. Then it can all just be warm in RAM, or your caches can be warmed up, and then it's super performant. So there's various things you can do to greatly mitigate the effects of state growth and the penalties that state growth does to both storage space. And storage space is less of a concern, right? Like storing a couple 100 gigabytes of state isn't that big a deal, right? It's not nothing, but it's also not the end of the world. It's the performance penalties that it leads to that's the real problem. But ultimately, there's no silver bullet of you just do this and everything's solved, except potentially for statelessness. I will say that the Fuel protocol was designed to be conducive to statelessness, unlike Ethereum's. For instance, to calculate an Ethereum code, so an Ethereum contract address, you would do something like take the hash of the init code, for example, right? Or some hash of the bytecode that's a proxy to the hash of the bytecode. Now, the problem is that you only have the hash of the bytecode, or you can get the code hash, but you can't get the Merkle root of the bytecode. So if you wanted to do something like stateless execution on Ethereum with the EVM, you would have to, every time a contract is called, you would have to provide the whole contract. Obviously, this is very expensive. It's the reason, it's one of the many reasons that stateless Ethereum never took off, because of this notion of you might want something better, like code being Merkleized. We do code Merkleization from the get-go because we knew this was a problem, because when the Fuel protocol was designed, it was designed to be conducive to stateless execution in the future. So, if it gets to the point that stateless execution really is needed, then it would be fairly easy to transition over the protocol to that mode if and when we get there, because it was designed from the ground up to be conducive for stateless execution.
Fascinating. Also, you mentioned the resource pricing, which is one of my favorite topics. I think watching your talks on that really was like a click in my understanding of a lot of this stuff. I think it'd be really useful to help people understand that you can control both developers and users' behavior via resource pricing, and that is something that can kind of force us to use resources in a completely different way. And you're basically setting the price on how to build contracts. And I think, just digging a bit deeper into that could be really interesting.
I can kind of do a brief recap of what I discussed at EthCC earlier this year, which is basically that the gas schedule that's on any blockchain, like Ethereum, like what Fuel will have, directs how people use the chain. And you could make a reactive gas schedule that's based purely on current benchmarks, or you could make one that's proactive, one that's based on expectations around the future and that shapes how people will act to create any future you want. Not even like expectations around the future, but you can actually shape the future to be what you want. Not just like assuming users do X, Y, Z, it'll look like this, but it's like, I want this, so I'll make users do A, B, C. As an example, imagine if Ethereum had gas cost for storage rights to be 100 times as expensive, right? Then people would optimize around gas usage of storage rights a lot, and they would use those storage rights very little, and they would use other stuff much more, right? So in that way, you can incentivize and kind of nudge particular behaviors in both developers and therefore users to do certain things and minimize negative externalities. The biggest of which is state growth, but there's other negative externalities that we may have to worry about. That's the biggest one, though. So something as simple as greatly increasing the cost to write to state means that now developers will write contracts that don't touch state a lot, and users will use those contracts, and therefore they won't touch or they won't write to state too much, and therefore they won't bloat it as much. So with something as simple as that, proactively making this change, you can completely change how users and developers use the chain, and therefore you can completely change the growth of, for instance, state over time, just by making a change to the gas schedule proactively under the expectation or under the kind of will to make the usage be a certain way. So you don't have to just sit there and say, well, I guess the gas schedule is whatever it is on the Ethereum's EVM. I guess I'll just take it if the usage increases 10x. No, you can actually proactively change the schedule to make the various negative externalities mitigated.
I also would bring up too that like a fascination of mine will be that the EVM was inherently a difficult system to build fraud-proofing systems around. And this led to sort of a lot of different kinds of solutioning and designs to bring about the EVM on the EVM, essentially, which was incredibly difficult and requires a lot of different planning and basically an interpretation architecture that is usually, well, currently like either MIPS or MIPS or WASM or something along those lines, and that's what a lot of teams are using. Fuel, because of its inherent design, is actually built for being fraud provable on a system. So every operation is actually designed with this in mind, which gives you much more interesting realities when it comes to building potentially rollups in an execution layer that's a fuel execution layer as well. And this is like still an area of research, so not to commit to anything with this particular design, but a lot of the rollup teams like to throw their problems into what is effectively layer 3. So it's like if the layer 2 isn't good enough, they're just like, well, we'll pass it off to layer 3. And there is something to it in the sense that what they're trying to say is well, we have this better fraud provable architecture here, but if we can't really necessarily address the problem at that level, then you go another level up into abstraction. And the benefit of that is that you're essentially, the state system itself is now being compartmentalized for this particular app. And so one area that I am looking forward to seeing is effectively an implementation of the FuelVM in the FuelVM, particularly for this case, only because, well, it can easily be considered a layer 3, but also that I have a hunch that for certain heavy state usage or heavy state applications, that particular solutioning might actually be, quite a valid area to look at. But it is something that's sort of less talked about and, we're less interested in currently. But thinking about the way the FuelVM actually is constructed and Fuel itself, actually building the instantiations of things like layer 3s and Fuel should actually be pretty straightforward, especially given the complexity and sophistication of something like Sway.
So just like having a naturally very easy to fraud provable VM, like makes it easier to spin up a layer 3 on top of it. That's generally the point. Cool.
Yeah.
Didn't think about that. And even just having a fraud provable system, it's also like, is it potentially possible that you could like ZK proof the FuelVM as well? Like, is that like, if you were able to put the EVM into a proof, I imagine it's similar, if not easier, to do that with the FuelVM.
Well, if anything, it should be easier to ZK prove than the EVM because it was designed to be closer to a bare metal machine in mind. So it should actually be, which happens to be easier to ZK prove. So yeah, if ZK Turing complete VMs take off, or for instance, RISC-0 takes off, and you can just compile any arbitrary code directly to RISC-0, similar to the Canon or Arbitrum Nitro architecture, right? Or you can compile it to just RISC-0 and boom, ZK proof for free. If any of those take off, then yeah, we just get them for free, basically.
So cool. Yeah, all this stuff sounds super interesting, and there's a lot of like interesting headway happening with the Fuel team and the Fuel project. So I think it would be like really helpful or interesting to hear like where we are and how soon can developers start working on this, and then what are the kind of the big milestones that we should be looking out for?
Yeah, for sure. So basically to kind of give, kind of future looking roadmap here. And, we like to do it in stages. So we think projects that throw out dates, it's not really a good idea. And given the technical nature of this, it's more of an understanding of the stages. But, basically in September, we launched our first developer facing testnet. So that was a huge milestone for us. And, right now we're doing iterations over the test nets, continually adding things and improving them. The next major stage after this is to do a test net that actually is bridged to Ethereum, which is going to be a huge moment for us because it's essentially an arbitrary message passing bridge, similar to what you see with systems like Optimism, but I'd say even better. And that'll allow kind of an incredible amount of flexibility and communication between Fuel and a Fuel execution layer and Ethereum. So that's really the next stage for us. And then after that, we're looking to do the full mainnet deployment of a Fuel sequencing node, so single sequencer node and Ethereum bridge. So that's the stage after that. And I think that'll allow teams to be able to ship to production with full interoperability with things like ERC20 tokens, ERC721s. It'll allow teams to build, for example, full NFT projects on Fuel, leverage all of the execution scalability benefits, but then be able to do things like settle NFTs on Ethereum or bridge assets both ways, etc. So you'll be able to bring all of the standard ERC20 tokens that you see on mainnet Ethereum into Fuel and have them work across things like account abstraction and our full kind of UTXO processing system. So I think it's going to be pretty exciting, but essentially that's where we're headed from a technical perspective. So yeah, we have 2 stages to go here, and that's more or less the technical details I'd say are significant from my perspective. But John, just to get into any other technical highlights.
Nothing much to add. That was pretty good. Although potentially it might also be worth reflecting on how far we've come.
Yeah.
At the beginning of the year, I think January, I want to say 2nd, 3rd, I don't know. We made all our repositories public, so everyone at that point could use our stuff. It was still very early days, very primitive. But since then, we've been developing in the open. This is different than many other projects that kind of just pop things into a repository out of nowhere. Not just our development, but also our planning, issue tracking, and everything is entirely public on GitHub. Just go into any repositories, follow what we're doing. There's no there's no secrets here. It's all it's all literally just there. The features that we're building, etc. It's all just there. Prior to our open testnet, which Nick said launched a couple of months ago, we did launch a SwaySwap demo. So this was a private testnet with a long-lived testnet with a deployment of SwaySwap on it, which was a port of the Uniswap v1 with some Uniswap v2 features that anyone could just play with. That demo is presumably going to be improved at some point in the near future to include things like a persistent wallet, both to use a persistent CLI wallet and then in the not distant future a persistent in-browser extension wallet, as opposed to like a burner wallet. But yeah, we've gone pretty far from just releasing some code which was a very long way to go to where we are today, which is long-lived public testnet already out, and more to come very soon.
Yeah, and I'd note just that the public repo is one of the more interesting repos to follow in blockchain space. I think there's been statistics about how it's one of the most like highest throughput in terms of commits, issues, yada yada, of Rust-based blockchain projects. And I think watching
now is a good time for me to show, which is that if you go on the Rust and blockchain newsletter, the Fuel project. Well, it is for only Rust-based projects and protocols, but at least in the Rust-based world, the Fuel protocol has been in the top 5 basically consistently for the past, I don't know, 10 months, 12 months. I don't even know when I started looking at this. The past many months. This is with the likes of Polkadot, Solana, Sui, Aptos. So it's consistently been in the top 4 or 5.
Yeah, and personally been watching it, and like you get a ton of learnings just out of the issues going through there, and a lot of the cool stuff they're working on. Plus, the Discord dev chat is one of the more interesting places to kind of, if you're trying to, as a developer, you're trying to look for places to kind of learn and ask questions. Like you go and ask a question in there, and John will respond within 15 minutes. It's pretty crazy.
Sometimes.
Sometimes.
Your experience may vary. User experience may vary, but yeah, I guess that's super exciting to hear from you guys about where the project is going and kind of stuff we can look forward to. I know once we have a bridge to Ethereum, I think it'll kind of open the floodgates in terms of people trying out new things, experimenting with all the different like feature sets that Fuel has. So maybe we could talk a little bit about like the developer experience around what this would mean for them. Like, are we launching with a Foundry equivalent or something like that? I think it could be valuable to talk about fork here.
Yeah, for sure. I think the way that at least I perceive developer experience going forward is there's sort of meeting the existing bar of what we experience typically with things like the Ethereum ecosystem, and sort of getting up to par with that level of tooling. And I think we're quickly approaching a point where we should have that level of tooling both on the optimization side and just on the general like testing and infrastructure side. In many ways, we've far surpassed what the tooling is for Ethereum. But in some ways, like compiler optimization, we're still improving things. Mind you, the language is, I don't know, a year and a half old. It did not exist a year and a half ago, and is now almost to a point where I think from a technical sophistication level is basically unmatched in terms of smart contract programming languages. So in terms of the sophistication of the tooling, it will be launching fully, and we already have right now, I would say, essentially a Foundry equivalent, and in some ways much better than a Foundry equivalent already. But that will continue to grow and improve. So once the sort of proverbial bar is met, and then kind of well exceeding it, we get into new territory where we actually start to explore what we call like the Fuel application itself. And the Fuel app is actually something that will be, I think, something the blockchain space has needed for a long time, which is a coherent publishing architecture for applications and libraries, and having a full decentralized ecosystem around that allows you to build and ship applications easily, quickly, efficiently, and knowing that we have a lot of great solutions around publishing now, both between just shipping to something every day like GitHub all the way over to Arweave and IPFS. There's a lot of incredible systems now that we're going to have available. So Fuel will move towards that vision of a coherent Web3 application sort of standard. And, there's a very kind of crazy future ahead with that. But that's basically the DevX that I'd say people can expect. But I think, John, if you want to add any more items.
Yeah, sure. I'll show fork a bit more, which is the short for Fuel Orchestrator. So it's our equivalent of Foundry or Cargo if you're using Rust. Like Nick said, in many ways, it's vastly ahead of what any other blockchain developer tooling provides. To kind of give kind of an example of this is we do have a build and dependency management system that is similar to Cargo's. It's different than Foundry's. For those of you who have used Foundry before, you'll know that it uses either just copy paste into into like just copy paste that git checkout into your local like directory, or it uses git submodules, and both of those are not so great, right? The just copy pasting is not exactly the best way to version something. It also creates a bunch of duplicates, etc. Git submodules are kind of horrific to work with, right? You always have to go like git submodule init, git submodule update, or whatever, right? It's just really it's a huge pain in the ass to deal with. Fork uses dependency management system that are the same as cargoes. So this means, building a nice dependency graph. You can declare your dependencies declaratively in a TOML file, and then it'll download them in a deduplicated way to some local home directory, exactly like cargo does. And this means that it's much easier to precisely version dependencies and also keep them updated and also properly distribute them around. And you can do all this without having to like finagle with git submodules or other weird stuff like that. It just works TM. And it took a lot of effort to get it to that point. And this is an example of where we really emphasize the superior developer experience over more classical tools in the Ethereum and blockchain developer ecosystem. Developer experience is a very huge core part of our values as a project. It's not just about scale. Developer experience is one of the central pillars that we kind of built this project on. And Fork is kind of an example of that. Something as little and as small as how do you manage dependencies is something that we spend a shitload of time on to get right. And that applies to other parts of the tooling as well. And it's in an amazing state already. In many ways, it's better than existing tooling. Sure, in some ways, it's not as good, but those ways are rapidly diminishing in number by the day as it's continually improved. And it provides a nice unified developer experience at Stack because all of our tooling is all kind of developed in-house and is guaranteed to be maintained, is guaranteed to be compatible with each other, etc. And those are guarantees that you don't get out of basically any other tooling, especially not in the Ethereum developer ecosystem.
Yeah, awesome. And it seems like things are really starting to come together in terms of where the language is, where the developer experience is, the orchestration engine. All of these things kind of feels like now is the time to get in to start building some Sway apps or some Fuel apps. So, like, what are some?
Well, you know what they say. The best time to start building Sway was
yesterday,
6 months ago, but the second best time is now.
But yeah, what are some applications that, like, if you had unlimited free time or you wanted someone else to experiment with some weird, interesting stuff, what are the things you're most excited about having people building?
I think from my perspective, definitely looking at all the different configurations of order book exchange design, just for all the different kinds of things you can do with that, I think would be pretty incredible. As well, again, leveraging Fuel's ability to do a lot of the high performance, smart contract computation is going to be like a great area to explore. We already had implementations of BLS 12381 and ED255 in Sway that runs on top of Fuel. So you can only imagine the amount of other things that could be constructed. As well, I'd say the existing DeFi systems are stuff that, continuing exploration on and figuring out different ways to implement and better ways to implement are always good. Whether that's like Uniswap, V2 or going to Curve or lending systems, all those things are great areas to explore, as well as like NFT systems. But I'd say that, again, the benefits here are that things like account abstraction will continue to improve to a point where the kinds of user experiences you can create with Fuel will not be like user experiences on other blockchains, to a point where everything from the wallet experience all the way down to the application experience is going to be far superior. And that's just a combination of a bunch of different designs that we have in mind. So, even just using SwaySwap, you'll notice things like approve and transfer from don't happen because you don't need it, because we have things like scripts. And that by itself is a huge user experience boost, considering it's so annoying to do that. And also now apparently extremely unsafe, because people just go unlimited with the approve and never take that off. So essentially all these little innovations end up compounding into a completely different user experience for people.
And these little, like, it's kind of developer mindset changes or design swapped. Like people have to kind of think about stuff differently. How are you guys pushing out like standards or stuff like that on how developers should be using this? Like since they're so used to Solidity or the EVM world where they're stuck with certain patterns, like how are you guys kind of pushing forward these new ideas?
So I'll mention on that front, we do have an RFCs repo. We decided not to create a fuel improvement process system because every blockchain does that, where I think it ends up becoming potentially unhelpful to do it that way. So we have a standard RFC process that we're continuing to improve over time. So that's like the Fuel Lab / like RFCs. In terms of kind of growing out the developer experience in terms of just templates, our kind of DevRel team has a significant amount of templates that are available, and as well we have things like an applications repo that has a very high grade and high standard of code quality that allows people to probably get a good sense of what an application should look like and how it should be laid out, and we'll continue to grow that out. I think we have a sense about ensuring there's enough default templates and things people can take off the shelf right away to understand how the application works. And we'll just be continuing to improve all the ways that you can actually pull, standard, examples and things like that. Look at how they run and actually get them running really quickly. Ideally, in our vision, we can hope that you can pull an app and actually deploy it to mainnet in under 5 minutes. That would be probably the most superior experience we can provide developers.
Yeah, so to expand on that, we do have a lot of examples, and the examples do demonstrate how to do things differently. For instance, token transfers, both accepting and sending tokens. Well, I mean, guess what? That's what SwaySwap does, right? So anyone can check out that code, and it provides pretty good instructions on how to do these things. With respect to developers coming from Solidity land, I will say that it's very easy to learn Sway. You can learn the syntax in 10 minutes. It's not super complex like Rust is. It's a very simple subset of Rust. So you can, if you know Solidity or any of these languages, you can learn the syntax in 10 minutes, basically. And the programming model is very similar to Ethereum, except when it comes to token transfers. That being said, anyone who has used Solidity for any length of time will hate token transfers and all the gotchas they have. Using transfer is horrible. You have to use extremely safe, actually safe transfer, but this time for real, by some other third-party system, by some other third-party library. If you really want to have safe ERC20 transfers that don't have weird corner cases. So anyone who's dealt with token transfers knows it's horrific. So saying they have to learn a new thing, it's like, well, thank goodness, because we've done it the way that they imagine it should be done, which is that you just forward coins with a contract call. So it's the simplest thing you can possibly do. So it's very easy for them to learn this because this is presumably how they're already wishing it was. And for new developers that are coming into the space, I think we provide some reasonably comprehensive but ever-improving documentation to onboard them. So even if you aren't familiar with smart contract development and you've never touched a blockchain before, don't be scared to jump into Sway and to developing on Fuel. There's no inherent barrier to entry to building on Sway that doesn't exist for any other blockchain. And we're doing our best to minimize that barrier to entry objectively.
Okay, maybe just before we wrap up, are there any other resources that we should highlight for interested developers? Anything in the way of a grants program or something on that front?
Yeah, for sure. So currently we're running a very, I would say it's maybe not the right word, but aggressive grants program. So if you do want to build on Fuel and you're looking for support and it's a good ecosystem project, we would love to talk. The applications for that, you can go to fuel.network and just under grants and apply. As well, I'd say a good resource to start is just going to github.com/fuellab/awesome-fuel. There's a ton of articles there and a ton of resources. That's a good place to get a sense, I think, about the Fuel technology and architecture. But as well, to be more practical, the Sway book is also really great. So I'd also recommend that. And then Cami, who heads our DevRel, has some incredible resources. And I think we probably link them in the podcast description, but she has a ton of stuff just on getting started and doing your first counter app and stuff like that, which I think is probably the most useful to just kind of get your hands into it. Yeah.
Awesome. Super helpful. Ryan, anything else on your end that you want to cover?
Oh, I guess John didn't get to mention his go-to apps that we should build here. The question before about what do you want people to build on Fuel? Yeah.
I want people to build. I don't know, come build some NFTs.
Okay.
Lots
Yeah.
of people want some NFTs, some generative NFTs, what have you.
Yeah.
Everyone loves NFTs or profile pictures, or I guess, what do they call them now? Digital collectibles?
Yes, it's the Reddit rebrand.
There you go.
Yeah.
All right, great. Well, John, Nick, thanks so much for coming on. For anyone who's interested, go ahead and give them a follow on Twitter at @JAdler0 and at I am Nick Dodson. And we'll be doing another episode that goes into more developer-specific topics and goes deeper on Sway and tooling in the future. So keep your eyes and ears peeled for that as well. But guys, thanks so much for coming on. This was great.
Thanks for having us.
Thanks.